Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to electrical and electronics measurement. And so far we have covered the performance parameters of measurement system, static characteristics and dynamic performance characteristics. So in this video we are going to discuss another important concept associated with the analysis of the data which is obtained from the measurement process. Okay, how to deal or how to analyze the data that we obtain from measurement so that we can get accurate results. Okay, the results which are close to the true value. Okay, so statistical analysis of measurement data. So some important parameters we'll discuss which try to give us the accurate results, okay, or to analyze the measurement data in a better way. So why we need to have this statistical analysis of measurement data? Now we all know that measurement is affected by a lot of things which cause deviation from the true value. It can be internal, it can be external. It can be because of the observer, his or her error, or because of the faulty instrument, or because of environmental effects, anything. The readings that we get, they are not always accurate. It is not the exact value of the parameter which we are trying to measure. It is always deviating from the true value. So what is done is that we take a lot of readings. A large number of readings are taken. By large I mean it can be 10, it can be 20, it can be 30, it can be more than that, 50, like that, depending on the requirement. And then we perform a lot of statistical analysis on those data. We calculate a lot of things, and then from those parameters we get a roundabout idea of what will be the closest value to the exact or true value of the measurement reading that we are taking. So some of those important parameters are mean or arithmetic mean, deviation, average deviation, standard deviation, then variance. So we'll discuss them one by one. So arithmetic mean is generally taken, we can understand it as the average of the number of readings that we have taken, and the most, the closest value of the parameter under measurement is the arithmetic mean. It is the best approximation, the close to the true value that we want. And generally number of readings is generally large, 10, 15, 20, 30, more than that also. So the arithmetic mean of, let's say, n measurements or n readings that are taken for a specific parameter is given by this. Let's say x1, x2, x3 up to xn, nth readings are taken. The arithmetic mean, x bar, is the sum of the measurement readings, all the individual measurement readings divided by the number of readings taken. Okay, this. So let us try to understand it with the help of an example. Let's say we have performed a measurement and we have been given with the following data. x1, let's say it is 49.7, x2, let's say we have got 50.1, x3 is equal to 50.2, x4 is 49.6, and x5 is 49.7. Now we have to calculate the arithmetic mean. So arithmetic mean, as I said, it is the sum of the individual readings up to x5 here divided by 5, which is equal to 49.7 plus 50.1 plus 50.2 plus 49.6 plus 49.7 divided by 5. Okay, so let us calculate it. 49.7 plus 50.1, 50.2, 49.6, 49.7 divided by 5. So it is coming around 49.86. This is the mean value, and this is the closest value that we can get to the true value of the measured parameter. This is the mean. Here we have kept the number of readings 5 so that we can simplify the calculation process. Generally the number of readings is very large, 10, 15, 20, 30, 40, 50, like that. So another parameter, which is deviation, that is deviation from the mean value. So it is the departure of a specific reading from the arithmetic mean value. Okay, so it is given by, for a specific reading, let's say for the first reading, the deviation is x1 minus x bar. For the second reading, deviation 2, d2 is equal to x2 minus x bar, and so on. For the nth reading is xn minus x bar. Another interesting thing is that the deviation can be positive or negative. If the specific reading is less than the mean value, the deviation will be negative. If it is greater, then it will be positive. And the algebraic sum of all the deviations is 0. So here, for this reading that we have here, deviation for the first reading, d1, is x1 minus x bar, x1 minus x bar, which is 49.7 minus 49.86, which is equal to minus 0.16, because it is lesser than that. Similarly, d2 is x2 minus x bar equal to 50.1 minus 49.86, which is equal to 0.24. Similarly, deviation for the third reading, x3 minus x bar, the third reading is 50.2 minus 49.86, it will be plus 0.34. Similarly, d4 will be 49.6 minus 49.86, which is equal to minus 0.26. And the fifth deviation is 49.7 minus 49.86, which is equal to minus 0.16. These are the individual deviation for the individual readings. Now let us say the sum of all these deviations. The sum of all the deviations, that is sum of deviations. It is starting from the first minus 0.16 plus 0.24 plus 0.34 minus 0.26 minus 0.16. So it is here 0.26, 0.16, it is coming around 0.42, and this is minus 0.58 negative, and here it is 34 plus 24, it is 0.58, which is equal to 0. Okay, so the algebraic sum of the deviations is 0, okay, as it is specified here. Then we have is another important parameter, which is average deviation. So the average deviation of the individual readings is given as the sum of the absolute values of the individual deviations divided by the number of such readings that are taken. Okay, so the absolute value means the negative ones, the negative deviations are converted into positive. So it is a very important parameter when it comes to the precision of the instrument, or the repeatability, reproducibility, all that one comes into play. It is a very important parameter which specifies the precision, okay, the consistency of the instrument to give a specific correct reading. Okay, so the average deviation again for this example is, let us calculate the average deviation. The average deviation will be absolute value 0.16 for the first reading, then plus 0.24 plus it is 0.34, then 0.26, 0.16 divided by 5, because the number of readings that are taken is 5. So it is coming, let's calculate. So it is 1.16 divided by 5. Again it will be 1.16 divided by 5. It is coming around 0.232. This is the average deviation. This. So average deviation. Then we have standard deviation. Okay, standard deviation and variance. So the standard deviation is given by this formula. Okay, the standard deviation which is given by sigma is given by the square of the deviations divided by the number of such readings, and then finally square root of that value. Okay, and generally when the number of readings is less than 30 or less than 20, in some cases you will find somewhere it will be written less than 20, in some cases it is written as 30. So when it is less than 30 or 20, the number of readings, in that case the formula is written as this. Okay, the squares of the individual deviations divided by n minus 1, then square root of that value. So here for this reading, okay, for this given data, the standard deviation will be given by this minus 0.16 whole square plus 0.24 whole square plus 0.34 whole square plus minus 0.26 whole square plus minus 0.16 whole square divided by n minus 1, which is 5 minus 1, 4, and then root over square root. So let us calculate it. Okay, 0.16 square, 0.24 square, 0.34 square, again 0.26 square, 0 minus 0.16 square. So it is around 0.292 divided by 4. So it is out of 0.073, and again square root of that, it is 0.27. This. Okay, this is the result. And then we have is what called as variance. So variance is simply the square of the standard deviation. Okay, so here the standard deviation we calculated is 0.27. So when we square root it, it will be coming 0.073. Okay, so this is the result here. Variance simply 0.073, square root of the standard deviation, that is variance. So you just remove the square root and it will be this. Again, for the number of readings when it is less than 20 or less than 30, in some cases you'll find this n will be replaced with n minus 1. Okay, so variance is simply square root of the standard deviation. So the square root removed will get this value, and for the number of readings less than 20 or less than 30, this n is replaced with n minus 1. So variance, just remember, is the square root, the square of the standard deviation. So here for this data, the standard deviation is 0.27 and variance is 0.073. Okay, so here are some of the important parameters related to statistical analysis of measurement data which we discussed. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you.